In this video, I want to talk about calculating a fit between two mating parts. And in this case, what we have is a hole through a part over here, and then we have a cylinder that we would like to fit into that hole. Alright, so let me erase out those little marks that I just made right there so we can get started on this. Okay, so first thing we want to look at is the diameter of the hole, and I'm going to put a dimension on here with the diameter of 1.00. This would represent the nominal size of that hole. And remember, the nominal size is the size that we can add or subtract a tolerance to, and then I'm going to put a tolerance of plus or minus 1/100th of an inch. Now I want to point out something about this 1/100th. Sometimes someone, when they're talking about this, they'll sort of imagine there's another zero on the end, and instead of calling this 1/100th, they'll call it 10,000ths of an inch, and when they do that, they're actually talking about the same thing. But just to keep the math simple, let's just keep this at 1/100th of an inch. Alright, so what that means is that the diameter of this hole, which has a nominal size of 1, can vary as much as 1/100th of an inch in either direction. That is, it could get larger or smaller by 1/100th of an inch, and this part would still, or that feature would still pass inspection. So what that could mean for us is that at its greatest diameter, that hole could be as large as 1.01. That would be, we start with a nominal dimension of 1, and we add 1/100th of an inch, and we wind up at 1.01. Now, the other limit of size for this hole would be when we take the 1.00 nominal size and we subtract 1/100th of an inch, which results in the hole's diameter being smaller, and it'd be smaller by 1/100th of an inch, so it winds up being 0.99. Now, the diameter of 101 and the diameter of 0.99 represent the limits of size for this feature. So what that means is that the diameter of this hole needs to fall somewhere between a diameter of 1.01 and a diameter of 0.99. If it does that, it will pass inspection. Now, there's a way that we refer to these limits of size here, and we refer to one of them as the maximum material condition and the other one as the least material condition. When the hole is at its smallest, it's actually at maximum material condition, which I'm going to represent by just writing MMC. And when the hole is at its largest diameter, it's actually at least material condition. Now let's think about that for a second. When the hole is at 1.01, when it is at its largest diameter, we've actually removed more material from the part. That's why it's at least material condition. When the hole is at 0.99, there's more material remaining in the hole because the hole is smaller, and that's why we say it's at maximum material condition. Alright, so let's try to design our cylinder to fit within that hole, and let's try to make sure that when that hole is at its smallest size, which is its maximum material condition, that this cylinder that we have over here will be 1/100th of an inch less than that. So really what we're going to try to calculate over here is what is the nominal size for this cylinder if we have a tolerance of plus or minus 0.01. Okay, well, the way we think about that all starts by coming over here and looking at our maximum material condition, because this is when the hole is going to be at its smallest. When the hole is at its smallest size, that's when we're going to have the most trouble making the cylinder here fit into the hole over here. When the hole is at least material condition, which would be at the 1.01, it's actually easier to fit that because the hole's larger. Alright? So, if we know that we're starting with the limit of size at maximum material condition of 0.99, then that tells us that the diameter of this cylinder, when it's at its largest, has to be 1/100th of an inch less than 0.99. So that tells us that the largest the diameter that this cylinder can ever have and clear that hole, which is at 0.99, is when this cylinder has a diameter of 0.98. And since the cylinder would be the biggest when it's at 0.98, we would say at that point that the cylinder is at MMC. It's at maximum material condition. So since the cylinder can never be bigger than 0.98, what we need to do is come over here and look at our nominal size again, and we're going to actually subtract the 0.01 from 0.98, which leads us to a diameter of 0.97. And 0.97 is going to represent the nominal size of the diameter of the cylinder. So that means if this is nominal, then we could even subtract another 0.01 from that and wind up at the smallest diameter for this cylinder at a diameter of 0.96. And since the cylinder would be at its smallest diameter, we would say that the cylinder at that point is at least material condition. All right. So the answer to our problem of nominal size plus or minus 0.01 for this cylinder, we've pretty much calculated now. So I'm just going to write that in and then we'll just run through it real quick. So at nominal size, the diameter of this cylinder is 0.97, and that would be with a tolerance of plus or minus 0.01. So if we think about that, again, that means that the largest the cylinder can ever be would be when we add 0.01 to 97. So that would give a diameter of 0.98. That would mean the part is at MMC, that the cylinder is at MMC, because it would be the largest. If we come back to our nominal size again of 0.97, and this time we subtract 0.01, the other limit that we could have on diameter for this cylinder is 0.96. That would be least material condition, LMC. All right, so when the diameter of our cylinder is at maximum material condition, it would be at 0.98. When the diameter of the hole right here is at maximum material condition, its diameter would be 0.99. That gives us 1/100th of an inch of clearance between these two numbers, and that's what we want as our minimum clearance. Now at the opposite end of things, let's think about what if the hole is made at a diameter of 1.01 and that our cylinder is made at a diameter of 0.96. So if we subtract 0.96 from this, what do we wind up with? All right. Well, we're going to wind up at a clearance of 0.05. So we really have a lot of clearance when the hole is at least material condition and when the cylinder is at least material condition. But when the cylinder is at maximum material condition right here and the hole is at maximum material condition right here, we have only 1/100th of an inch of clearance, and that was what we said is our minimum clearance. So this is the process that that a designer would go through to calculate the clearance between those two mating parts.